How are you? I'm going to solve the exercise number 6, the one in here. So we are going to have a charge number 1 that is minus 3 microcoulombs, charge number 2, 8 microcoulombs, and charge number 3, 7 microcoulombs. So you need to determine the resulting force or the net force in here and the angle it forms with respect to the horizontal axis. So for that, first of all, you need to calculate the hypotenuse in here, that is the net force, and then remember that to solve the right triangle, you can use the Pythagorean theorem and the trigonometric functions. So first of all, we can calculate the force between the charges Q1 and Q3 from here to here. So F1 3 it's equal to K, that is the constant 9 times 10 to the 9 newtons times square meters per square coulombs in here. So times the charge number 1 minus 3 microcoulombs minus 3 times 10 to the minus 6 coulombs in here, and then 7 times 10 to the minus 6 coulombs, and then all divided by 0.5 meters. So you could use in this case your calculator, the one over here. Okay, so the one over here, so I'm going to use this calculator. It's 9 times 10 to the 9, and then minus 3 times 10 to the minus 6, and then 7 times 10 to the minus 6, and all divided by 0.5 squared. So I missed that value here. So is this value here is square. So the force from from the charge number 1 to the charge number 3, it's equal to minus 0.756 newtons in this case. So this value and this value, this one and this one, and square meters with the square meters. So we need to calculate the force between the charges 1 and number 2. So it's the same or similar, 9 times 10 to the 9 newtons times square meters per square coulombs divided by the force number 1, that it's minus 3 times 10 to the minus 6 coulombs, and then the charge number 2, 8 times 10 to the minus 6 coulombs, and all divided by 0.5 meters squared. So we can substitute the value in here, only the one in here, that it's a number 7. So the result, the force from 1 to the charge number 2, it's equal to minus 0.864 newtons. So in this case, only the sign in here, so this one over here and this one over here, is telling you that the force is going this way, so it's attracting to each other. So that's all. So in this case, Q2, for example, is higher than Q1. So this charge is going from here to here, and then Q number 3 it's higher than Q number 1. So the force is from here to here. So the charge, and then to calculate the hypotenuse or the net force, you need to use the Pythagorean theorem. So in this case, the net force it's equal to the square root of 1/3 squared, and then F12 squared in here. So it's this one, something like this. So the net force it's equal to 0.756 without the signs, and then minus F12, that is 0.864 newtons, and then you can use the calculator again. So in this case, square root, it's this value here, 0.756 squared, and then plus sorry, in here it's plus, and then 0.864 squared, and that's equal, so the net force it's equal to 1.15 newtons. And then to calculate the angle with respect to the horizontal axis or the x-axis, you can use the tangent. So the angle it's equal to the tangent minus 1 to the minus 1 times the force in here, so it's F13, so that's 0.756 newtons, and then divided by minus 0.864 newtons. So again, you need to use your calculator. So tangent minus times 2 minus 9, it's minus 0.756 divided 756 divided by minus 0.864. So let me see. No, this is incomplete in here, so I need to put this value in here. So minus, no, so it's with this one, 0.864. so the angle in here is equal to 41.19 degrees. So that's all, guys, for the exercise number 6, and then we need to work with the exercise number 7. Thank you.